Right now, your entire galaxy is falling. Not drifting. Not coasting.
Falling towards something so massive it doesn't even have a proper name yet.
And the terrifying part? We can't see it.
In the next 8 minutes, you're going to understand what the Great Attractor actually is, why it took scientists decades to even admit it existed, and what it means for everything, every star, every planet, every atom of you.
Here's something your physics teacher probably skipped.
The Earth orbits the Sun at about 67,000 miles per hour. The Sun orbits the center of the Milky Way at about 514,000 miles per hour. Already, those numbers should make you feel small.
But the Milky Way itself?
It's barreling through space at roughly 1.3 million miles per hour relative to the cosmic microwave background, the faint afterglow of the Big Bang.
That's the baseline hum of the universe. And against that backdrop, we are moving. For most of the 20th century, cosmologists assumed that motion was basically random. Galaxies scatter in every direction as the universe expands.
You'd expect motion, sure, but chaotic motion.
No particular destination. Then, in 1973, astronomers started noticing something they couldn't explain. The cosmic microwave background, that perfect, uniform glow from 380,000 years after the Big Bang, wasn't quite uniform.
On one side of the sky, it was slightly hotter. On the other, slightly cooler. A difference of about 1 part in 1,000. That tiny temperature difference meant we were moving.
Not randomly. Directionally.
Something was pulling us toward a single point in the sky in the direction of the constellation Centaurus.
And the pull was enormous.
We're talking 14 million miles per hour on top of everything else.
Scientists called it a peculiar velocity.
A polite word for something deeply strange.
Because here's the question nobody could answer: what could possibly be massive enough to drag a galaxy? Astronomers gave it a name in 1986.
The Great Attractor. And the name alone should tell you how seriously they were taking this. It sits about 250 million light-years away from us, in a region of sky that, for decades, we literally could not see.
The Great Attractor lies almost perfectly behind the densest part of the Milky Way's own disk, a region astronomers call the Zone of Avoidance. Our galaxy's dust and gas and billions of stars blotted it out, completely invisible light. We knew something was there.
Something pulling not just us, but hundreds of other galaxies, the entire local group, the Virgo cluster, galaxy after galaxy, all streaming in the same direction.
And we couldn't look at it directly. Think about that for a moment.
Imagine hearing a sound so loud it shakes your house, but you're not allowed to turn around. When X-ray and radio telescopes finally punched through the Zone of Avoidance in the 1990s and 2000s, what they found was a supercluster of galaxies, a massive gravitational concentration called the Norma cluster at its core. Thousands of galaxies packed together, along with enormous clouds of hot gas and, almost certainly, vast quantities of dark matter.
The total mass concentrated in that region?
Estimates range from 10 quadrillion to 100 quadrillion solar masses. Numbers so large they stop feeling like numbers and start feeling like philosophy.
And yet, even that wasn't the whole story. Here's where it gets stranger.
Because by the early 2000s, better data was revealing something uncomfortable.
The Great Attractor might not be the destination. It might just be a waypoint. Astronomers mapping the velocities of thousands of galaxies noticed the flow didn't stop at the Norma cluster.
The streams kept going.
Past it. Through it.
Toward something even larger, lurking another 500 million light-years beyond. They called it the Shapley supercluster, the single most massive structure within a billion light-years of Earth. A concentration of galaxies so enormous it contains the mass of tens of millions of Milky Ways. And it turns out, the Great Attractor itself is falling toward that.
We are caught in a gravitational cascade.
Like a raindrop pulled to a stream, pulled to a river, pulled to the sea. But before we get to what this actually means for our future, and trust me, the timeline on this will recalibrate something in your brain, you need to understand the force that's fighting back.
Because there is something pushing just as hard as these structures are pulling. Dark energy. The mysterious pressure embedded in the fabric of space itself, accelerating the expansion of the universe. It doesn't pull. It pushes everything apart. Right now, dark energy and gravity are locked in a slow cosmic arm wrestle. The Great Attractor pulls. Dark energy expands. And here's the critical detail: dark energy is winning the long game. In a few 100 billion years, the expansion of the universe will be so extreme that even galaxies currently falling toward each other will be torn apart and flung beyond each other's observable horizons forever. So our galaxy is falling toward the Great Attractor at 14 million miles per hour, and will never actually reach it. The universe will stretch the distance faster than gravity can close it. You're watching a chase that was lost before it began. In 2014, a team of researchers led by astronomer Brent Tully published a paper that reframed everything. Using a new technique to map the flow of galaxies through space, not just their positions, but their velocities, their directions, their gravitational allegiances, they drew the largest map of our cosmic neighborhood ever constructed. And what emerged from that data was a supercluster. Our supercluster. 500 million light-years across. Containing 100,000 galaxies. With a total mass of 100 million billion suns. They named it Laniakea, a Hawaiian word meaning immeasurable heaven. The Milky Way is not a lone galaxy wandering through space. We are one member of a vast gravitational family, all flowing, all falling, toward a single point they identified as the gravitational heart of Laniakea. They called it the Great Attractor. The thing we couldn't see, couldn't explain, couldn't name properly for 40 years, turned out to be the center of our cosmic home. We weren't being pulled toward something alien and foreign. We were falling toward the middle of where we already belong. And we had no idea. Here's how to hold this without your mind shutting down. Every morning you wake up, you are aboard a planet, orbiting a star, spiraling through a galaxy, which is itself flowing through a supercluster 500 million light-years wide, all of it drifting in a universe so large that Laniakea itself is just one bubble among millions in the cosmic foam. You are not small because you're insignificant. You are small because the scale of what contains you is genuinely, mathematically, staggeringly immense. And yet every atom in your body was forged in a star that was part of this same flow. You are not a passenger in the cosmos. You are made of it. The Great Attractor isn't pulling your galaxy toward oblivion. It's the gravitational heartbeat of the structure you've always lived inside, you just couldn't see it yet. If this broke your brain a little, good. That means it's working. Subscribe, we drop one of these every week, and next time, we're going into the void. Literally. The cosmic voids between the filaments, regions of space so empty, so impossibly large, that scientists aren't sure the standard laws of physics fully apply inside them. You don't want to miss that one.